10.8 grams of ammonium sulfate is dissolved in enough water to make 100 milliliters of stock solution. A 10 milliliter sample is taken and added to 50 milliliters of water. Calculate the concentrations of ammonium and sulfate ions in the final solution. So first I'm going to have to find the moles of ammonium sulfate, then I'm going to find the concentration of that stock solution, then I'm going to find out the amount of moles that I add to the second solution when I take 10 milliliters of the stock solution. Once I have the moles, then I can figure out the mole to mole ratio when these ions disassociate, because ammonium has a +1 charge and sulfate has a -2 charge, so there's going to be 2 ammoniums for every 1 sulfate, so they won't disassociate 1 to 1. After I figure out how many moles of each there are, then I can figure out the new volume, and then I can figure out the new concentrations for each individual species. So now I'm going to start off by figuring out the molar mass of ammonium sulfate. Ammonium is NH4 plus, and sulfate is SO4 2 minus. So the formula would be NH4 2 SO4. And I can look up the molar mass for that, and I already did, so I don't feel like wasting my time doing that. And the molar mass, well, let me just write this out. So 10.8 grams of NH4 SO4. 1 mole ended up being 132.13 grams. This is equal to 10.8 divided by 132.13. So this is equal to 0.0817 moles. So I figured out how many moles 10.8 grams is. I dissolve it in enough water to make 100 milliliters of stock solution. Molarity is in moles per liter, so I need to convert 100 milliliters to liters. So 100 milliliters is just 0.1 liters. I do that, and that's going to be equal to 0.817 molar. So that was simple enough. Now that I have the concentration, I then take this stock solution and I take out a 10 milliliter sample and I add it to 50 milliliters of water. So the next thing I need to do is figure out how many moles is in that 10 milliliters, and I can do that because I have the concentration and I can just multiply it by 10 milliliters. 0.817 molar NH4 2SO4 times 10 milliliters. 10 milliliters, I'm going to have it in molarity, so I need to convert those 10 milliliters to liters. And 10 milliliters is 0.001 liters. Do that multiplication. Just going to move over the decimal 2 places, and that's going to be equal to 0.00817 moles of NH4 2SO4. So now that I have the moles, I've added this many moles of NH2SO4 to 50 milliliters of water. And that also includes the 10 from before. So the total is going to be, so the total volume for the final solution is going to be equal to 60 milliliters. 50 that I'm adding it to, and then 10 from the original. So that's also useful to make note of, because I could have very easily just made a mistake and done the final concentration in 50 milliliters, so I thought I'd just do that ahead of time. But I'll remind myself again later. So I have the moles of each. Now, as I said before, ammonium has a +1 charge and SO4 has a -2 charge, so when they dissociate, if I were just to write this out, so if I have NH4, that's N4, that's not it, NH4, 2SO4, and I dissolve it in water, it's going to dissociate to 2 NH4 plus SO4 2 minus. And I forgot to write aqueous, but obviously I'm dissolving it in water, so it should be assumed that they are aqueous. But anyways, I have 0.00817 moles of NH4 2SO4. So when I dissolve this, it's not going to dissolve 1-to-1 for NH4 at least, so I'm going to calculate that real quick. So I have 1 mole of this stuff, and I get 2 moles of NH4 plus. So that's just going to give me this times 2. And this is 0.01634. And I'm going to round that off. And then obviously this other one reacts 1-to-1. This is 1-to-1, and this is 1-to-2. So I'm going to have, in my final solution, 0.0163 moles of NH4 plus and 0.00817 moles of SO4 2 minus. And as I said before, it's critical to know that even though I'm adding it to 50 milliliters, I also include the volume of the original, 10 milliliter sample. So the total volume is going to be 60. So to calculate the concentrations of each one, I divide by 60 milliliters. But I have to convert that to liters, obviously. And 60 milliliters is 0.06. Oh, I forgot to continue writing this. So the molarity is 0.272 molar NH4 plus, and then for SO2 or SO4 2 minus, it's going to be the same thing except 0.00817 moles. So 42 minus, I was about to write plus, what I meant to do was a minus. And again, it's same amount of final solution. 0.00817 divided by 0.06. 0.136 molar SO42 minus. And these are the final concentrations.